Okay, in 7.1, let's look at an example from your textbook. Let's look at number 17. It says total plasma volume is important in determining the required plasma component in blood replacement therapy for a person undergoing surgery. Plasma volume is influenced by the overall health and physical activity of an individual. Suppose that a random sample of 45 male firefighters are tested and they have a plasma volume sample mean of X bar equal to 37.5 milliliters per kilogram. Assume that sigma is 7.50 milliliters per kilogram. Find a 99% confidence interval for the population mean blood plasma volume in male firefighters. What is the margin of error? Okay, so let's write down, if you watch the lecture video for 7.1, he suggests writing down the information you know. So I know my random sample is 45, therefore N equals 45. It also tells me that the sample mean is 37.5. That means X bar is 37.5. And I'm going to go ahead and put my units here, milliliters per kilogram. Assume that sigma is 7.5, so that's the population standard deviation. Now it says find a 99% confidence interval, so my confidence interval I'm looking for, or my C, is 90%. We can also write that as 0.90. Okay, so we're going to look for the confidence interval here. So a couple things we want to recognize is that we know the population standard deviation. So since we know this population standard deviation, we are going to use a z-interval, the standard normal interval. The other thing to observe is our sample size is larger than 30. So the problem does not tell us that the underlying distribution is normal, but because of the central limit theorem, with this sample size being larger than 30, we can assume that the sampling distribution is a normal distribution. Alright, so in part A, it asks us to find a 99% confidence interval. So in the lecture videos, you will see with Dr. Mosley, he does use the formula for these. So we're going to go ahead and use the calculator. So remember, our favorite button is Stat. We're going to go over to Tests, and you'll see number 7 is the z-interval. Sorry about that. So we choose number 7. Now the question on the calculator is going to be, do you have data or stats? Okay, it gives us the statistics. It doesn't actually tell us the data. In section 7.3, we'll have quite a few, or I'm sorry, 7.2, that have lists of data. So we have the stats, so we arrow to stats, hit enter to select it. We input the information we have, 7.5, X bar is 37.5, N is 45, confidence level is 0.9. And we calculate it. Now the way we want to rate this, especially when it comes to a test, is what we're trying to estimate is the population mean. So mu is going to go in the middle, and then our two values will be on the end, 35.661 and 39.339. Okay? So I'm going to skip ahead to part C here where it says interpret your results. I'm going to go ahead and interpret it. Finding the confidence interval we can do with the z-interval. And then interpreting it, we always are going to say we are 90% confident that what we're estimating, population mean, and we got to say what that population mean is. And that's going to come back from your problem. What you were estimating. The population mean blood plasma volume in male fighter fighters. so that the population mean blood plasma volume in male firefighters, is between 35.661, and this is important where you show the units, milliliters per kilogram. I will be specifically particular about that. And 39.339 milliliters per kilogram. So remember what the confidence interval is saying is if we took 100 samples of size 45, 90 of them, the population mean, the mean would be in this range. Okay? So let's back up just a little bit to part B where it asks us, the second part of part A here is what is the margin of error? Now if you watch the video and you see the formula on how to calculate the margin of error, remember he does it in the calculator video. The margin of error is Z critical times sigma over the square root of n. And Z critical, this is the margin of error. Z critical comes from our table. Okay. Remember when we calculated these using this formula, we took the sample mean, added this number to get this one, and subtracted it to get this. Okay, so if mu's in the middle, and we have this interval here, the way that we find half of it is we would just subtract these two and divide it by 2. And that will also give us our margin of error. So we can use the formula looking at the table, or once we have the interval, subtract them and divide by 2. So we have 39.339 minus 35.661 divided by 2, 1.839. So our margin of error is 1.839. So in part A, we've calculated our confidence interval, our margin of error. Part B asks us what conditions are necessary to do these calculations. The two conditions are that the underlying distribution was normal, and that's because our sample size was larger than 30, and that we knew the population standard deviation. We interpreted the results. Now in part D in this problem, it asks us to find the sample size necessary for a 99% confidence level. Okay, so for part B, it's changing our confidence level to 99%. And now it wants us to find the sample size. So in this problem, we do need to use the formula for sample size. And there's no shortcut way of doing this on our calculator. In this particular problem, it tells us find the sample size necessary for a 99% confidence level with maximum margin of error 2.5. So it tells us E. So we know E is 2.5. And we knew in the problem it had told us sigma was 7.5 milliliters per kilogram. So we're going to plug these numbers in. Well, so you're going to say, how do we get Z critical? So this one we do have to actually look in our table for this problem, this particular value. So if you look at your table, in the front inside of your cover or the pullout, you see this little table at the bottom. That's the easiest place to get these Z criticals. So depending on your percentage, our percentage here for part D is 99%. So my Z critical is 2.58. So I have 2.58 times my population standard deviation divided by my margin of error, all squared. So I put this into my calculator. If you want to go ahead and do that. We have 2.58 times 7.50 divided by 2.50 all squared. And we get 59.90. So what you want to remember for your sample size, no matter what your decimal is, even if this would have been 0.1, we always need to round up. So our sample size necessary to get that confidence level is 60.